Okay, so we have this problem before us, which says the path of a football when thrown is modeled by the equation y equals 20 minus x plus 0.1, where x is the horizontal distance and y is the vertical distance from the point where it is thrown. And then we have a whole bunch of questions we need to answer. But before we jump into these questions, I first want to graph this equation. So let's come over here for a second and do that. So when we're graphing things, we want to find my x-intercepts and my y-intercepts. So let's begin by doing that. Let's begin by finding my x-intercept. So to do that, I'm going to let y equal 0. So I'm going to have 0 equals 20 minus x plus 0.1. And then going to set each of these equal to 0. So I'm going to have 0 equals 20 minus x. I can then take x to my other side and be left with x equals 20. Then over here, I will have 0 equals x plus 0.1. I can take my x over to the other side, which will make it negative, which eventually will mean that I'm going to be left with negative 0.1. So here are my two x-intercepts. So I could come over and quickly plot them on. So I'm going to have one here at 20, and then another one here at negative 0.1. Next, I'm going to have my y-intercept. To find my y-intercept, I'm going to let x equal 0. So I'm going to have y equals 20 minus 0, 0 plus 0.1, which just means I'm going to be going 20 times 0.1, which means I'm going to be left with 2. So that is going to be my y-intercept. So I come over to my graph, y equals 2 is there. Now, before I graph it, I need to figure out whether my parabola is upside down or upright. And if you look over here, the tip-off should be this negative in front of the x here. If I was to rewrite this another way, I could take that negative out and be left with x minus 20, x plus 0.1. So if I were to fully expand that, my first term, the a in front of my x squared will be negative, which means it's going to be an upside down parabola. So knowing that, let me now graph this parabola. It's going to look like this. Perfect. And because I'm only dealing with height, I obviously don't have to go below my y. And remember, this sketch is more or less just to help us answer the question. If the question itself was asking us to sketch it properly, we would spend a bit more time doing this, but this is just to help us visually know what we're doing. Okay, so having done that now, the first question is asking of us to find the height from where the ball is thrown. So immediately by looking at our graph, we can see the height from where the ball is thrown is going to be y equals 2. 2 right here. This is the height from where the ball is thrown. And the way we could solve that if we hadn't drawn our graph is realizing that the height from where the ball is thrown will be its initial point. So it will be when x equals 0. So when x equals 0, my y is going to equal 2. Next, how far away is the ball when it strikes the ground? So how far away is the ball when it strikes the ground? So here you can see it's going to be when x equals 20. So I would say here it's going to be x equals 20. So when x equals 20, that's how far away it's going to be when the ball strikes the ground. Next, we need to figure out what is the maximum height of the ball, the maximum height of the ball. So it's asking me to figure out what this point is here. This point is here. So I need to figure that out. To figure out what the maximum height is, I'm first going to figure out what is my x going to be to produce my maximum y value. And to figure that out, all I need to appreciate is the fact that it's going to be halfway between 20 and negative 0.1. So I'm going to go 20 plus negative 0.1, and then I'm going to half that. So find the average of it. So that's going to be 19.9 over 2, which is 9.95. So this right here is 9.95. So now I need to figure out what my y output will be for that. And to do this, I'm actually going to use my CAS, and I'm really going to use this as an example, as an excuse to show you how to answer a question like this on your CAS, because questions like this are just really great to use your CAS for. So let me bring that up. Where's my CAS? Here it is. Okay. So what are we going to do? So we're going to graph it. So I'm going to click here. I'm going to add a graph. Let me look about what it is. I'm just going to call it F. I don't want to call it F1. It's going to be 20 minus X, X plus 0.1, enter. There we go. We can't really see it. Let's go menu. Let's go window zoom. Let's zoom out. Good. Let me now just get a better picture of it by putting a box around it. So let me do this. There we go. That's nice. Let me bring that here. Perfect. So it's asking me to find what the maximum height is going to be. So I'm going to go menu. I'm going to go analyze graph. And I'm going to go maximum. And then I'm going to start here, bring it across. And there we go. Now, it's telling me that my answer, so we found out it was 9.95, and then it's going to be 101. Now, the annoying thing about the CAS is that when we're in the graph mode, sometimes it's not going to give us all the decimal points that we need. And the way that you fix that is by going menu, settings. At the moment it's on float 3. Let's make it float 7. Okay. So as you can see, it's 101.0025. It didn't give us that before. And when I initially tried to fix that, I went into on, and I went into settings, and I went into document settings, and I changed it here, but it doesn't change it for the graph here. To change it on the graph, you need to do what I did before, and that is when you're in the graph, you have to go menu and you have to go settings. So that's just a really good trick to know, that if you aren't seeing enough decimal places at the end in the graph, you have to change it within the graph itself. Okay, so that's going to be our answer, 101.0025. Perfect, so now I can come here, and there's your answer. Y is going to be, well, I rounded it up a bit there. Okay, next, we need to figure out, when is the ball less than 10 meters high? When is the ball less than 10 meters high? So let's come up here and look at our graph. So we know that here, this is 100. So this isn't very realistic, because I don't think someone could throw a ball 100 meters high in the air. Maybe they could. I can't. All right, so that's 101. And now we're at 10. Well, this is, let's say this is 10 here. Let's say this is 10. So there and there, we're going to have two intercepts. So when y is 10, we're going to have two x-intercepts. So we're going to have one here and one here. And what we want to find is when the ball is less than 10 meters high. So that means it's going to be all these values between x is negative 0.1 all the way to here. And then it's going to be the same logic over here. It's going to be less than 10 here and here. So I need to figure out how to solve this now. So how could you go about this? As you can see here, how I've really operated is by picturing y equals 10 going across. Whoops, I did not want that to be that color. Let me try again. What I did is that I pictured y equals 10 going across here. And then because it said less than 10, I'm picturing everything below this line. So if you wanted to solve this, one way you could go about it is coming to your CAS and coming to your graph, oops, and going, all right, let me hit tabs and let me hit 10. So I'm putting 10 in, and then I can see this line here. And then if I want to now find the intersection points, I'm going to go menu, I'm going to go analyze graph, and I'm going to go intersection. It's going to be there to there. So there's one, menu, analyze graph, intersection, there to there. So as you can see, oops, I want to pick it up. We have one there, 1 there. So it's going to be 0.41 and 19.489. So now when we come and put our answer in, remembering these numbers, so I've written them down beforehand because I thought I'd forget. So here are my numbers that we found. So we found that here is going to be 0.410 and here is going to be 19.49. So therefore your answer is going to be, when is the ball less than? It's going to be when x is the subset of, and it's going to include it, negative 0.1 all the way to 0.410. It says less than, not less than and equal to, so it's going to be an open bracket, the union of open bracket 19.49, and it's going to include 20. It's going to include a square bracket. So remember, square brackets, because I'm including this negative 0.1 and I'm including 20, but because it says less than, not less than or equal to, is going to be open brackets here. So that's how I solved it. So that's just one way about going about it using your CAS, putting a line in. If you didn't want to do that, we could add a calculator, and we could say, all right, we have f, and see how my f is in bold? That's because I've defined it as a variable, and that's because it's really carried it over from the graph. So now, actually, I want to solve it. I want to solve when f of x equals 10 for x, close my brackets. Whoop, error, computation. CAS computation is restricted in CAS off and exact method mode. I have never seen that before. Let me go. So this is a bit in the action settings, document settings. It said something about CAS mode. Okay, let's put CAS mode on. I don't know why that was it. Calculation mode, auto, that should be fine. Okay, let's now go back to it. Let's hit, okay. So there was a bit of a in the field, things go wrong. So when things go wrong, just read what it told you. It told me something was going wrong with the CAS. I went into settings and I fixed it. All right. So there you go. They're the same results that we saw before. 4.410 and 19.49. So that's another way you could solve it. In terms of defining variables, I should go over this now, just in case you're having a bit of issue with defining variables. So let me clear the variable. So I'm going to go actions, and I'm going to say clear all A to Z, and that's going to clear all my variables. So now when I put an F in, it just looks like a normal F. It isn't bold. If you didn't want to graph it, but you simply wanted to define what F is, there's a few ways you can go about it. The way that I would recommend that you go about it is by going define F of x equals, and then you could write out our whole formula again. What is it? It is 20 minus x plus 0.1. Done. So now when I put the F, it's bold. Perfect. Let me now, so yeah, that's all right. Let me now clear that menu, actions, delete variable, clear all A to Z rather. Okay. Another way you can do it is you hit F, then you go control this button here, and you get that. Then you can type it in. So I can't be bothered typing in that thing again. So you type in whatever you want. Oh, make sure you define it. Make sure you say that. And you've done it again. So we just defined it again. So now if I type that in, I'm going to get out what I put in. So there are two different ways you define it. So all up, there are three ways you can define something. You can define it in the graph, and then when you come to your document here, it's already going to be defined, or you can define it using define, or these two dots. Hopefully that was helpful. We covered quite a bit in this question. We went over a bit of graphing, how to solve things if you're not getting the right decimal places, and we also answered this question. Hopefully that was helpful, and if you're having any troubles with any of this, please don't hesitate to let me know.